Okay, so to recuperate or to recap whatever happened. So we had it where she took one step and I took two steps, and as we moved forward here, we found that every one step she took, I took two, and I was not more just always 2 steps ahead. I was 2 steps ahead, then I was 4 steps ahead, then I was 6 steps ahead, then I was 8 steps ahead, right?
Sure was.
So yeah, so that's what happens as we're going linearly. We're gonna do the same thing circularly. Okay, so can we make this right here? You're gonna need to you be on the inside, I'll be around on the outside, okay? So I don't think this is gonna work because you're gonna take like a step here, and then here, and then here, and then here. Can you see that?
We should go into the hall.
You know what? I got a better idea. Here we go. Here we'll go arms. Arms in a circle. Okay. So these are our different locations. We've got we're going to 45 increments. Okay, and then over here. Yeah, I know. And then down, and then 270, and then over here. And then got it. All right. So every time Rosa says march, I'm going to move 2 steps, and you're going to move 1 step. Okay.
Okay. I believe in you, man.
All right.
Okay. March.
1, 2.
March.
1, 2.
March.
1, 2. Oh, look, hold on. What's going on?
Oh, snap me.
She, well, yeah, almost, but no
you're
dabbing. Okay, so,
no dabbing.
all right, so she's at 180,
She's
right?
at 180 here.
I'm at 360. You see that? Okay, all right.
Oh, March.
1, 2.
March.
One. You're doing fine.
March. Thanks.
1, 2. Okay.
Oh. Ooh, March.
1, 2.
Oh, you met.
I caught up. Yeah. Did you see that?
Whoa, you just left.
All right. Okay. All right. So I want you, Hannah, just to kind of go at a 1 Mississippi. Okay. Can you do that? There you go. Now, while you're doing that, in her 1 Mississippi, I'm going to go around twice. Get it? All right. So just do 1 Mississippi. 2. Can you just do that?
Yeah.
Okay.
1
right.
Mississippi. 2 Mississippi.
See, I'm going 2 times around. See that?
Mississippi.
Okay, wait, again.
She's still going.
Good
She's
job.
like, I can see that.
Yeah, all right.
See that.
All right. So let's think about what that would look like if we were graphing, okay? Graphing what I'm doing. Here's her graph right here. Up, down, back to center. All right, if you can tell here, I've put the tick marks here at pi over 2, pi, 3 pi over 2. This is 2 pi. This is 6.28. So what would my graph look like? If I'm going around 2 times by the time...
Would yours go down? Would it be small? Would yours go down lower? I mean, like, you know what I mean? Like, no, I would do it.
There would be more of them?
There would be more of them. I'm going this whole entire pattern here, up, down, back to center, by the time that she's only at halfway. So when she's right here at pi, at 180 degrees, I've already gone up, down, back to center. I've already gone. See what I'm saying? And by the time she makes this other circle, or this other half cycle, I've already gone like that. Does that make sense? Okay. So let me show you what that looks like. That's going to look like this one right here. Y equals sine of 2x.
Aha.
So the original function is the blue. All right. Notice when she's at halfway, I've already gone up, down, back to center. Then when she does this little half cycle right here, I've already gone up, down, back to center. So I've gone around 2 times in the time that she's only gone around 1.
You slow.
All right. So yeah. All right. Any questions on that? No? Okay. So what about this? I'll draw them over here. So sine of x. What's the period of that normal one, the blue graph, the first one? How long does it? 2 pi. So we notice here as that frequency increased, so sine of 2x, what's the period now? It is 1 pi, yeah. Let's go ahead and change this again, make a prediction. If I say the sine of 4x, so basically for every 1 step that she takes, I'm taking 4 steps. Okay. What do you think that's going to look like? Anybody make a prediction? Ashlyn, I can see your wheels are turning here. Go ahead and make a prediction. What do you think? Okay, possibly pi. Well, you're jumping here, but that's fine. Let's hold off on the period here, but just tell me what do you think it's going to look like?
Oh, it's going to be more.
Like
Okay, so we're thinking a higher frequency.
Yes, those
All right.
are the scientific words.
Yeah. Okay, things gonna go zoom, zoom, zoom.
Yes.
Okay. I don't know why I raised that. Okay, let's go here. So 4x. Here you go. Are you ready? All right. So watch out. So here's 2x right there. 4x. Definitely a higher frequency. It definitely is going zoom, zoom, zoom faster. Okay. Another way that we could say is that it takes sort of that graph and it squishes it in, it compresses it in horizontally. We'll go ahead and put that down. These are some of the things you write down. But you don't write that stuff down. Let's see. I go up, down, back to center right here. By the time this original function just hits its maximum. Does anybody remember where the original sine graph hits its maximum? Not at 1. 1 pi is right here. This is half of that. This is pi over 2. So yeah, it goes up, down, back to center, up, down, back to center, up, down, back to center, up, down, back to center. So actually, yeah, it does 2 whole cycles by the time we get to pi. So that's why I was kind of holding you off on that one. It's not pi, it's pi over 2. Some of these things, we'll call this, eventually we get here, sine of bx. So y equals sine of bx. As b increases, we could say the frequency increases. That's how frequent it's going up and down, okay? So the frequency increases. We could also say that the period changes. Is the period getting larger or smaller? First it was 2 pi, then it was pi, then it was pi over 2. Yeah, the period is decreasing. And as a general rule, we could say the graph gets squished or compressed horizontally. That's sort of like a visual way of talking about that. Are we recording, Michaela?
Yeah.
Okay, great.
We weren't.
Graph compresses along the x-axis. Okay? Let's go ahead and see what happens when I have the sine of 8x. We've looked at some data. We've kind of noticed a trend. Okay? We've made sort of like a general rule, like a predictive statement here. Okay? So we're going like this is like an hypothesis. Let's go ahead and test that hypothesis. We would guess that this 8x would have higher frequency, a smaller period, and it would look like the graph compressed, right? Let's see if we're right. Sine of 8x. And here we go. It absolutely did. Congratulations. Am I teaching science or am I teaching math here? Okay, so we tested our hypothesis, and there we go. This right here is pi over 2. If you notice here, we go up, down, back to center, up, down, back to center 2 times before pi over 2. So pi over 4 is absolutely correct. Is that period there? Now, the question is, what if I put a generic b right there? So any number. What would the period be? What's the formula? How am I going from this? Here's a hint. I've got a 1 right there. From 1 to 2 pi, 2 to pi, 4 to pi over 2, 8 to pi over 4. B to, what would be the period right here? Anybody know off the top of their head? Let me make it a little bit easier for you. So, if I have an input of 1, then the period is 2 pi. That's a 1 right there. If I have 2, then it's pi. If I have 4, it's pi over 2. If I have 8, pi over 4. Not sure what I'm saying? Like, these are the different numbers that we tested. These are experimentally what we found to be the case. Okay? What I'm saying is obviously there's a relationship from here to here, here to here. And it's that same relationship. what is that relationship? What is that formula? Jeremy, got any ideas? Not sure? Rosa, go ahead. Or Nick, or that table in general.
2 pi would be.
Yes, it is. 2 pi over b. That's the formula. Okay? So look at it. 2 pi over 1 is reduces to 2 pi. 2 pi over 2 reduces to pi. 2 pi over 4 reduces to pi over 2, 1 over half. 2 pi divided by 8 reduces to 1/4 of pi over 4. And so therefore the formula is 2 pi divided by b. Absolutely. So the formula here is, if you have y equals sine of bx, then the period is 2 pi divided by b. All right? We've looked at the data. We've made a hypothesis. Let's go ahead and put that hypothesis in harm's way. Let's go ahead and create another experiment that's going to test that hypothesis. I'm going to say sine of 1/2 x. Right? So if I've got a sine of 1/2 x, the period, using Rosa's formula, would be 2 pi divided by 1/2. So use your fraction math, that's 2 pi times, flip the reciprocal, flip the denominator, so 2 over 1. So 2 pi times 2, so 4 pi. We're predicting that the graph of sine of 1/2 x is going to have a period of 4 pi. Now what would that look like?
Very long.
Yeah, very long, stretched out, right? It goes up, down, back to center, but not by 2 pi, but by 4 pi. Let's go ahead and test that out. So replacing sine of 8x with sine of 0.5. Whoa. I'm going to zoom out. And I'm going to change from -1 to 1.
Whoa.
That's still, we don't like that, do we?
Not really.
Let's go -5 to 5. There we go.
Yeah.
Okay. So the blue graph is our original friendly sine x. So up, down, back to center by 2 pi. Up, down, back to center by 4 pi. But the black graph, which is a little bit hard to read, but you can still kind of see it there, it goes up, down, back to center, all the way. It takes a lot longer. It's kind of stretched out. Can y'all see that? All right. So this time I shall be the sine 1/2 x. Okay? So you're just going to go your normal 1 Mississippi. What am I going to do? I'm going to be slow in it, right?
You're gonna win!
That's why. This is for you, Ann. All right, go ahead.
Yay! 1 Mississippi.
Keep going.
2
Okay.
Mississippi. 3
I
Mississippi. 4 Mississippi. 5.
See what I'm saying? So yeah, okay. So every time she goes around twice, I only get to go around once. You can take a seat now. Great. So that's why you can see she goes 2 times, up, down, back to center, and then I've just gone up and down, back to center. So in the end, you win
Thank you.
the final analysis.
Thank you.
So we would say, as B decreases, the frequency decreases.
Spreads out.
Frequency decreases. The period increases. Right? We saw it went from 2 pi to 4 pi. And the graph, what's the opposite of compresses?
Spreads out.
Stretches? Yeah, okay. Stretches along the x-axis. T, C, H, yes. So yeah, it's like we've taken that. Let's see if I can inspect this guy. There we go. that's a little more visible now. So it's like we've taken that blue graph and stretched it out. Okay, how are we feeling about this? Pretty good? All right, let's go ahead and do some Alex topics that relate to this. This is called a frequency shift. We'll call it like a frequency scaling, I guess. But
Thank you. Oh, I got. Why do I feel scared?
all right. Number one is a terrible number one. Number two is a better number one.
Nice.
Number one is a better number two. So let's go to number two. All right. So number two actually deals with cosine, but good news, the cosine follows the sine pattern. Okay, so I mean, they both have 2 pi as their period. Their frequency is also going to be adjusted accordingly. All right, Rose, I want you to make sure you're with us here. All right. So, and Michaela, get that camera. Make sure we're holding the screen properly. All right. So here we have cosine of 1/2 x. I might write this as cosine of 0.5x. So my b value here is 0.5. All right, and so therefore the period is going to be 2 pi over 1/2, or 2 pi over b. I think we just did this one, didn't we?
Yes.
I'll write it again here. So 2 pi, it's the numerator, times the reciprocal of the denominator. So 2 over 1. So the period is 4 pi. Now let's make it very clear. The cosine graph starts high, ends high, in the middle it's low. The period is that right there. Period is from the beginning to the end. So sort of like till it comes back to where it was in the direction. Okay? So we're going to now graph our cosine graph. I'll start by just having baseline. No change there. My maximum value, my amplitude there is 1, so I've got a maximum of 1 and a minimum of -1. And cosine starts off high, so I'll put a dot right there. And it ends high, but the period on this one isn't 2 pi. The period, as we said a second ago, was 4 pi. So that means I'm going to kick over 4 pi units, which is all the way over here. And that's where I'm going to put my second dot. And then right in the middle, we're going to go low. And then I know that the cosine shape here is that goes from high to low. So right in the middle of these 2 points is where I hit the x-axis. Right in the middle between these 2 points is where I hit the x-axis. And then we connect that with nice, smooth curve. So it's kind of interesting. It is more important to know like the general shape of cosine and sine than it is to know exactly those coordinates. You know, to know that it crosses the x-axis of pi over 2 and 3 pi over 2. That's not as important as knowing the general shape: high, high, low, midpoint, midpoint. See what I'm saying? Because those things are going to change. Especially as we deal later on here in a few minutes with vertical shifts and amplitude shifts and frequency shifts. Okay? So, but no big deal. One step at a time. All right. Any questions on this one? By the time today's finished, you're going to have 4 new Alex topics that you can get just like that.
Yeah.
So, which, by the way, by Thursday, 3:30, another 15 are due. Short week. So, all right. Now we'll do number 1, which, as I said, is better number 2. So we've got 3/4 here. So that's my b value. So therefore, the period is 2 pi divided by 3/4. So do your fraction math. Numerator times the reciprocal of the denominator. 4/3. So 2 pi times 4 is 8 pi over 3. So that means my sine graph, the period, is now 8 pi over 3. Now, I would almost recommend just ignore that pi. Just say like, okay, it's 8/3, because everything here is in terms of pi. So just think 8/3. And so I can almost imagine that instead of pi, this is like 1. And this instead of 2 pi, this is like 2. 3 pi, this is 3. 4 pi, this is 4. It's just multiplied by pi, but I say, okay, this is also multiplied by pi, so I'm looking for 8/3. If we look here on the 1, and we look at the tick marks, we have 1, 2, 3, 4, 5, 6 tick marks, which means that this first guy is 1/6. And the second one over here is 2/6. Okay? Well, 2/6 is 1/3. Everybody with me so far? I gotta figure out where the heck 8/3 is. Alright? Well, 2 boxes is 1/3. So I would go another 2 boxes, and I'm at 2/3. Another 2 boxes, and I'm at 3/3. Well, duh, 3/3 is 1. Okay. Another 2 boxes, I'm at 4/3. Another 2 boxes, I'm at 5/3. Another 2 boxes, I'm at 6/3, which is 2, duh. Another 2 boxes, I'm at 7/3. Another 2 boxes, and I'm at 8/3. So this right here is my 8/3 pi, okay, or 8 pi over 3 rather. So that's going to be my ending point. So my sine graph, I draw my lines here. Midpoint, maximum. I'm not going to erase all that nonsense. 6/3, 7/3. And then I'm just off to the races. I'll go ahead. I know how to graph sine. Sine starts at the baseline, ends at the baseline. Now in the middle it's at the baseline. If I count these out, there should be 16 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 16. And then, so halfway through should be 8. So 1, 2, 3, 4, 5, 6, 7, 8. So there's a way that I can find the middle point. And halfway between these two, so 1, 2, 3, 4, is where I'm going to go high. And halfway between these two, 1, 2, 3, 4, is where I'm going to go low. Now I did a lot of things there, specifically about the scale and the 8/3 and stuff like that. So I want to leave it open for someone to have a question here at this point. Anybody have a question? Earlier in my other class, we had about 3 or 4 questions at this point. That's why I'm kind of pausing here. Mia, did you get this part right here? Like how to calculate the period?
Yes.
You got that, okay? So, Michaela, did you understand how I kind of found out that each one of these was 1/6, and then so therefore 2 of them would be 1/3?
Yeah.
And Nick, you got it where I'm like, where I was going like 2 boxes is 1/3, 2 boxes is 2/3, 2 boxes. Does that make sense? Okay. Anybody have a question? All right then. Okay. So, the really neat thing about ALEKS is that when it asks you a question, and then they have you graph it, they're going to change where the grid lines are so that your dots, your 5 main dots, are going to hit at an intersection. Okay? So that's really nice, like intersection here, and then the spacing is always going to be a 1/3 pi or a 1/6 of a pi or a pi over 4, or whatever. It's going to be in nice, friendly increments. Okay, so that way you're not going to have to go somewhere like 2/3 of the way between here. You're not going to have to worry about that. It's very graph friendly. All right, if no one has a question here, we're going to move on to number 3. All right, let's move on to number 3. Oh no.
Ah, interesting.
Stephanie, what's different on number 3?
Now, did you, instead of having this sign, it gives you continuous sign.
Okay. And that's the amplitude. Okay, 5/2. Does anybody know what that is as a fraction or as a decimal? 5 halves? 2.5. So 2.5 times the sine of 3/4 x. Let's make a prediction. That 3/4 right there, is that going to be a little bit compressed or a little bit expanded? Okay? Why?
Because the smaller it's
Okay, yeah, no, I like it. The smaller it gets, the closer this is to 0, then it's going to be kind of expanded a little bit. You're absolutely right. And 1 is the breaking point. Okay? If it's bigger than 1, then we're going to have a higher frequency. If it's lower than 1, then we're going to have a lower frequency, and it'll be stretched out. Great. So that's our v value. So therefore, our period is going to be 2 pi divided by 3/4. Isn't that what that other one was? Okay, so 2 pi times 4/3, so that's 8 pi over 3. So it's pretty much exactly the same, assuming this is divided into 6. 1, 2, 3, 4, 5, 6, it is. Okay, so I remember that this is box 16. This was 6/3, so box number 16 right there. There's my baseline. I probably should have done this part first. So always draw my baseline, and then my amplitude is 2.5, which means I'm going to go up to 2.5 for my maximum line, and down 2.5 from the baseline for my minimum line. And then we remember that sine starts off at the baseline, ends at the baseline, and in the middle it's at the baseline. So that was the 16, so, or the 8 count. So 1, 2, 3, 4, 5, 6, 7, 8. Halfway in between there, we're up high, so 1, 2, 4, and then 1, 2. And Hannah, you said it was going to be stretched out a little bit, didn't you? And if you look there, there's your 2 pi marker. That's sort of like you know where that normally would end there, and this is definitely stretched out. Good prediction there. Yeah. As a table, I want you to attack number 4 there. When you get it, call me over. Yes.
Okay, so you said that we have to do the reciprocal of it, so would it be 2 pi over 9 if you do 1 over 3?
No, you keep the numerator intact.
Okay,
So 2 pi.
so 6 pi?
Yes.
Okay, that's what I had at first, but then
Yeah,
that's
because-
not on here, so that's why I'm confused.
Okay, hold on. Erase this times 1/3.
Okay.
So make this fraction bar really big, because that one right there, that's the really big one. Okay, so we'll say equals
Okay.
2 pi times, and now do the reciprocal.
1 over
Sorry.
3?
Yes. Okay, now so that's
2 pi over
2
3.
pi over 3. Okay, I was wrong when I said 6 pi.
Okay.
So it's 2 pi
Okay.
over 3 is what you're,
Okay, so it's this, okay.
so it's going to be 2/3 of pi. Sort of like,
So, right here?
that would be 2/6.
So right here,
Yeah.
okay.
And it's cosine.
Yeah.
Yep. Go. Oh, you all have it?
Oh,
I agree. Your period?
I
Yes.
drew mine on the wrong one, so this
Okay,
one's
that's fine.
yours.
Alright, so the period is 2 pi over 3. I agree. Now, just like 2/3, right? So this is like, so that's like, okay, yeah, so right there. So that's,
But it still starts.
it's gonna start there, and this is where it ends. So remember, cosine starts high and ends high. So this dot it needs to be up here. Okay.
Start
Start high and ends high.
Oh,
What do y'all have for the period? You said the period was 2 pi over 3. So 2/3, if you imagine, is right here. So there's 1/3. And this, okay. Also, did y'all change the amplitude?
yes.
Positive 2, negative 2. So here's 2/3. Here's 2 pi over 3. Starts high, ends high, and right in the middle. So 1, 2. We're at the low point.
Oh, so it's like super.
It's stretched out and it's compressed.
Okay.
It's stretched out vertically, and it's compressed horizontally. So halfway between these two it hits the baseline, and halfway between these two it hits the baseline. So what we're looking at, something.
Oh, whoa. I
I understand now.
So you can see the 2 stretch that out vertically, the 3 compress it in horizontally. Because if we were to go through here, it would look like. So far, so good? Robbie, you good on that one? Okay. Stephanie, yes?
I was thinking, wait, you're right, and I was like, do we start here and then go down? I don't know where to go.
Ooh. All right, let's go ahead and look at number 5 together. I see several things that are going on. What do y'all see? Plus 2 at the end. So that's a vertical shift. Yep.
So now the baseline.
So yeah, shifted up to. What else do y'all notice?
It's the negative half.
There is a negative up front. Yep. So that means the whole thing is going to be inverted. Yep. What? And also you saw the 1/2. So that means our amplitude is 1/2. And what about this 1/2? That's our frequency shift. 1/2 is going to stretch that out. Okay. So our period, 2 pi over 1/2. So that's 2 pi times the reciprocal, 2 over 1. So 4 pi for the period. All right. I would kind of draw these steps in the same order that we just kind of walked through them. Shift it up 2, so here's my new baseline. amplitude of 1/2, which means I'm going to go 1/2 above the baseline and 1/2 below the baseline. Oh boy. There's 1/2 above. There's 1/2 below. It's pretty narrow road there. Now, where does sine start? High, low, baseline. Baseline. Okay, so that's convenient. Starts at baseline. The period we saw is 4 pi. So baseline again over here at 4 pi. And then right in the middle, we're also at the baseline. And as one of you already suggested, remember that -1 out front tells us that sine is inverted. So this is what negative sine x looks like. It goes low, then goes high. So halfway between these 2 points, I'm low. Halfway between these 2 points, I'm high. There's your 5 points. Hit the graph button, and you've got it. Really don't have a musical analogy to a shift. You know what I mean? Like I've been talking about, like an amplitude is louder, and a frequency change makes it go higher or lower. Okay, but a vertical shift, it's not really. Don't really have it. So I'm sure y'all can handle this one as well. Yes.
Yeah.
Just tell me out loud very quickly on number 6. What is the -1? Shifts down. What is the 5/2, which is 2.5?
It's the amplitude.
Amplitude, yep. So the negative then tells us that instead of starting high, it's going to start low. And the cosine 3x tells us that this is going to be a higher frequency, going like that. Okay? Number 7 is 7 and 8 are actually, or just 7. 8 there. I don't think I gave you 8. This is another ALEKS problem. So I'm actually teaching you 4 ALEKS problems today. Okay? And this one is super easy. They say here's an equation. All you need to tell me is the period and the amplitude. We can do that really quickly. What's the amplitude?
2.
2. And the period? 2 pi divided by 2/3, which is 2 pi times the reciprocal. So, yeah, it is 3 pi. Alright. Now, I'm going to tell y'all something here because we have less than 1 minute. Anybody might want to make a prediction? What would sine of 100x look like?
Oh my goodness.
What do you think? Oh my goodness, crazy? Or oh my goodness, boring?
Super. Yeah.
Yeah, super zoom. Alright? There it is.
Oh my. Me. Wait. Hannah. She said.
It's going up and down 100 times before it gets to 2 pi.
Oh my goodness.
Alright, now, your cell phone is broadcasting in the megahertz range. Okay, mega means million. Also, so millions of times a second, you've got those oscillations. Okay? We'll do some fun stuff next week as well.